Imagine an object so extreme and brutal that it could actually kill a black hole. These are Gravastars, cosmic soap bubbles filled with pure energy and shielded by impossible matter. To understand them, we must look at how the most massive stars meet their end. Stars many times larger than our Sun die in the most dramatic way possible, a supernova. In less than a second, the core collapses under the weight of its own extreme gravity. The outer shell rushes in, bounces against the core, and explodes with incredible brightness. Depending on the star's mass, there are usually two well-known outcomes for this collapse. Outcome 1 is a super-dense neutron star, a city-sized ball of pure atomic nuclei. Outcome 2 is a black hole, where reality breaks and everything collapses into a singularity. A point with no dimensions, where the laws of the universe simply stop making sense.
But what if there is a third option? Something even weirder than a black hole.
Instead of a singularity, the core might be ground down into pure energy. Imagine atoms being crushed so hard they transform into a bubble of repulsive energy. This bubble wants to expand violently, just like our entire universe does. It smashes into the star's falling mass, creating a standoff between two unstoppable forces.
Like an ancient god hammering on an anvil, matter is forged into a new material.
This process creates the shell of the Gravastar, a material at the limit of physics. It looks like a cosmic soap bubble, but it feels incredibly solid and cold. The shell is the coldest thing in the universe, just a fraction above absolute zero. In deep infrared, it is even darker than the cosmic microwave background. The shell isn't made of atoms. It's made of a new, unique, and extreme matter.
We don't even have a name for it yet, but it's at the very edge of nature.
The shell is so thin that atoms look like giants next to it. Yet it is so tough that stretching it by 1 meter would require a supernova's energy. Inside, things get even weirder. It is a perfect vacuum, completely empty of matter. There's not a single atom or particle here, just nothingness. But this vacuum is boiling with the most fundamental energy in the universe. To understand this, we need to look at what nothing actually is.
The inside of a Gravastar breaks our brains because it's a super-condensed nothingness. In our world, you can't have waves without water. Physics is similar.
Particles like electrons and photons are just waves in an underlying cosmic fluid. This fluid is the vacuum. What we see as nothingness is actually a fundamental ocean.
The space around you is almost entirely vacuum, filled with inherent energy.
A Gravastar takes this vacuum and compresses it as much as physics allows. It has 1 billion trillion times more energy per cubic centimeter than normal space. From the outside, a Gravastar looks and acts exactly like a black hole. Both curve space and trap light in glowing rings, slowing down time as you get closer.
Wait, gravity is pulling me apart before I even touch the surface.
your remains would be ground down and converted into the interior's vacuum energy.
So if they look the same, how do we know which one is real?
Black holes were just a mathematical theory for over 50 years.
Few believed they actually existed until we saw stars being thrown around by invisible giants.
We even took a picture of one, making them common sense in modern science.
But black holes have a problem. The singularity breaks our best understanding of physics. They seem to delete information from the universe, which shouldn't be possible. Gravastars solve these puzzles by avoiding singularities and keeping information safe.
Of course, they create new problems, like needing that weird exotic matter for the shell.
When two of these objects collider, they create gravitational waves, ripples in space-time.
Two black holes colliding should sound like a bass drum, a deep, quick thump.
But two gravastars would sound like a gong, leaving subtle echoes behind. Scientists are listening for these echoes in the music of the cosmos.
Observing the acoustic fluctuations near the Gravastar.
It's hard to tell them apart because their gravity is so strong it mutes the music.
We need much sharper technology to hear the difference clearly. Gravastars might answer physics' biggest questions, or they might just be another idea.
But this is why we do science, to learn that reality is different than we thought. Discovery is an ongoing process, and our partner Brilliant makes it easy to learn. They offer thousands of interactive lessons on everything from programming to physics. You can even explore the physics of black holes with their hands-on models. Start your free 30-day trial today and build your problem-solving skills. Let's conduct a few stellar experiments in our own lab.
First, we add some more mass to this protostar. More.
We've just created a blue giant, 10 times the mass of our sun.
Now we add 10 million years and see what happens next.
A supernova. And look, it leaves behind a perfect black hole.
Now we record our findings. Be careful to preserve the sparkle.
Our work is now available as a special poster for you to take home.
Every product you buy directly funds more videos for our channel.
Thank you for being part of our story and making this possible.
For more updates and fun, follow us on our social platforms. The interior energy creates a repulsive force that stops the collapse.
It's a delicate balance between the vacuum pushing out and gravity pulling in.
This shimmering surface is the only thing we would ever see of a gravastar. While black holes have horizons, gravastars have physical, solid boundaries. Anything that hits the shell is immediately converted into pure radiation.
The energy release is incredible.
It's like a continuous explosion on the surface.
Gravity still bends space, exactly the same way a black hole would.
We are looking for tiny differences that could prove the shell exists.
These secondary ripples are the echoes that scientists are searching for.
The universe is full of secrets that we are only beginning to uncover.
If gravastars are real, they change everything we know about the end of stars.
Every new theory brings us one step closer to the truth of our reality.
The hunt for the truth never ends. We just keep looking.
Science is a journey through time and space, always evolving. There is always more to learn out there. Always. From birth to death, stars are the engines of the universe.
And their final moments create the most extreme objects we can imagine.
We did it! Another cosmic mystery explored. Time for a break before the next big discovery.
The universe is a wonder, and we are lucky to be its observers. Until next time, keep looking up and stay curious.